In number 7, we're asked to show that the following two sets of symmetric equations represent the same line. Well, things are the same line if they have the same point and they point in the same direction. So let's identify directions. So there's a couple ways we can do this. On the answer page, I'll put it into vector format and compare them. Here, I'll just show you real quick the direction of this one. So we'll call it M1 is 8, 2, negative 2. And M number 2 direction would be negative 4, negative 1, 1. Well, there's a scalar multiple between these two. I hope you would agree that M1 is actually negative 2 times M2. Right? Since they're scalar multiples, they point in the same direction, that means they are parallel to each other, at least parallel. Our question wants us to prove they're actually the same line. So I've proven they're on top of each other. I just have to prove they're the same line now. I can do that by using a point on one and proving it lies on the other line. So let's take a point. Let's take the point from line 1. The point from line 1 is negative 7, negative 1, and 5. That lies for sure on this line, right? If I can prove it also lies on the other line, then I've proven they're the same line. So how do I prove that? Well, this is an x. Sorry. This is a x, a y, and a z. So let's use our symmetric equation, this one, and substitute for x, y, and z. So we'll get negative 7 minus 1 over negative 4 equals negative 1 minus 1 over negative 1 equals 5 minus 3 over 1. Let's see what happens. We get negative 8 over negative 4, negative 2 over negative 1, and 2 over 1. Or in other words, we get 2 equals 2 equals 2. This point is on this line. So because the point is on the line, and I know they're absolutely parallel, these two lines must be the same. Okay. And I could have gone the other way too if I wanted to use the point from this equation and the other line. It will work exactly the same.